Today what we're going to look at is a new type of equation of a line. We've already worked in slope-intercept form. That was y equals mx plus b. But this is point slope form, and this is going to be a little bit different form, but it's a little bit easier to help us figure out the equation when we have some missing information. So the point slope equation of a line, make sure you add this to your notes, looks like this. It is y minus y1 equals m times the quantity x minus x1. Now here's what's really, really important about this. You'll notice that one y and x have the subnumber 1 on them, and the other y and x don't have one. That matters. They are two different variables. Y and x, the ones that don't have any numbers on them, those you're never going to change. We're never going to plug anything in for those. We're going to leave those right there because those are going to be the x and the y that end up in your final equation. But so here's what the rest of it stands for. M, just like it is in every other kind of equation, stands for the slope. And then x1 and y1 is a point on the line. So that's going to be an ordered pair that is given to you, just like in the slope formula, how we have x1 and y1, okay? So let's look at where this equation comes from so you understand a little bit about it. So if we start with the slope formula, the y2 minus y1 equals x2 over x1, let's just pick one of the points. We're going to keep one of them xy that I don't know about, but let's pick a different point. So I'm going to just pick some random numbers. Let's use 2 and 3. It doesn't really matter. So what we can do here is plug that in for one of my points, and the other one I'm going to have be x and y. I'm going to have this be x2 and y2, and this be x1 and y1 in my formula. So y2 minus y1, that would be 3 minus x equals, actually I did these points backwards. Let's do these the other way around. So we have x1 and y1 and x2 and y2. That makes more sense. So when we set this up, we're going to do y2, which is y, minus y1, which is 3, over x2, which is x, minus x1, which is 2. And that's going to be equal to m. Now, something that we use in math a lot to solve problems is called a proportion. You saw these in 7th and 8th grade. So if I put this over 1, remember we can cross multiply with proportions. So if I multiply y minus 3 times 1 times anything is just itself, so that's going to be just y minus 3. And then when I multiply m times x minus 2, we get this. This is exactly where the point slope formula comes from. You see, this is our y and this is our x that don't change, and then this was our point y1 and x1. And then the m we would have to know and plug in. So that's just kind of an idea of, this equation wasn't just made up. It comes from the slope formula, and that's why we can use it. It's very useful for writing equations when the slope and y-intercept aren't as easily determined as the problems that we did yesterday. Yesterday we did ones where we knew the slope and we knew the y-intercept. And so, like I mentioned, we're going to start taking away more and more bits of information and seeing how we can still work backwards to figure out the equation. So let's look at two examples here of using this point slope formula. So if I am given a slope and a point, but not the y-intercept, so I don't know what b is, that is when we want to use the point slope formula of the line. And that should make sense to you. When we were given slope and y-intercept, we use slope-intercept equation. But now when we have slope and a point, we're going to use the point slope equation. So let's look at the example that we have here. Example 1, write an equation in point-slope form of the line that passes through the point -8, 3 and has a slope of 1/4. The first thing that's really important to notice is that we want our final answer to be written in point-slope form, okay? Then they gave us two things. We have an ordered pair. Remember we said that's x1 and y1. And then we have our slope, which we know is m. So I'm going to take that information and plug it into the point slope formula, which is this. So, like I said, these two don't change. We keep those the same, but everything else we're going to plug in. So looking at what we were given, we have y minus y1, which is 3, equals m, which is 1/4, times x minus -8. Now, remember, we should always try to simplify these things when we're done. And so what I see right here is that I have double signs, and we never want to have that, so we're just going to fix that. Minus minus is really plus. And they want us to have our answer in point slope form, and that's what this is. So there's the equation right there. We don't change anything about it. We just leave it. We can see all of our pieces. Here's our y1, our m, and our x1. And so that's the answer. The last thing that we're going to look at is what if they want us to change that equation into slope-intercept form. So if we look at example B, it says write an equation in slope-intercept form of the line that passes through the point 2, -1 and has a slope of -3. So the fact that they want our final answer in slope-intercept form is really important. That is y equals mx plus b. But we don't want to use y equals mx plus b to start because, again, we don't know b. We have, again, a point, x1, y1, and we have a slope, which is m. So if those are what I'm given, I want to use the point slope formula. So we set it up again. Y minus y1, so this time y1 is -1, equals m, which is -3, times x minus x1, which is 2. But this time, we're not done because we want to change this to y equals mx plus b, which means I need to move stuff around and get y by itself. So I'm going to do two things in this next step. I'm going to fix my double sign, and I'm going to distribute my -3. So I get y plus 1 equals -3 times x, which is -3x, and -3 times -2, which is positive 6. The last thing I need to do to get y by itself is to subtract 1. And so now I have y equals -3x plus 5. So now if I wanted to graph this, we can see that now we know the y-intercept is 5. So we have m and b now instead of having our x1 and y1. And so that's it. That's all we're going to practice today. Make sure that you got all of these notes copied down, and I will see you later.